If you want to create a replica from existing dictionary, we use like this, like from keys. Say like previously we created many things. Say like I want to create the say character frequency. From this character frequency, I want to create something. So I can do like, so I can create a new dictionary. Say like, alphabets is equal to an empty dictionary. And I can say that alphabets. So the only difference is that first the key dictionary should be present. Then I can say that alphabets is equal to alphabets dot from keys of say character frequency. And if I give the default as 0. Now if I say that alphabets is equal to, did you see what are is in the char frequency? Same old characters you got, right? So this from keys, if you want to use, the only constraint is first that new dictionary need to be created. From that new dictionary, we need to update like this. This syntax may be slightly difficult for beginners, but this is how you need to follow. After that, so if I go for the dictionary operations further, so we have seen like how do you, dictionary operations. If I say further, what else we have is like we have seen how to work with and doing the things. Now further, let me take one more example. So if you want to create an empty dictionary, this is how we create an empty dictionary, right? Either you can use the braces or like this also. But Pipit recommends that you do like this such that it would be easy. If you create like an empty dictionary, you can just add all the values. So if you want to add the values like this, and if you want to update the values also like this only, update. So like new values if you want to add, or if you want to update on existing thing also you can add. But like what if you have multiple values and if you want to update at one shot? Say like in this language dictionary, I have one more thing, say like Python dict. So I have one more dictionary called as the name, so maintenance, something I have. This is another dictionary. So I have language is one dictionary and Python dict is another dictionary. Now I have two dictionaries. Can I do so plus operation? So in a set, we cannot do a set plus operation, right? In the same fashion, for dictionaries also, we cannot do the plus operation. Means dictionary concatenation is not possible. Then what if you want to add two dictionaries? So one value means like this you can update. What if you have a more number of values you want to update? Either you do for loop and each time you update. So that is a very bad way of doing. Then best way is like using update. If I do languages.update, then what are the values are there in the Python dictionary? I mean the second value. So you can see that it is happening. So language.update of Python dictionary, you can see that it's happening it. So first thing, so what's the conclusions that we can draw here? So what we have seen is that the first dictionary is modified, but the second one is not. So the keys are present. If the keys are present, the values are updated. If the keys are not present, values are retained. Means from the second dictionary, when you are updating, if both have same keys, the latest values of second dictionary will go to there. If not, the first one will be there. If both are not present, it will add it. So hope it's clear. Like this, we will update like any new keys. And similarly, if you want to update one value at a time also, you can take. But after updating, let's say if I want to check the second value, did you see the second value is not changed, second dictionary? So in the same fashion, for the second dictionary, if you want to add one more, so I can do like this, say, as it is not having a div version, already it is having a div version of 3.9. If I update like 3.9 dot something, it will update it. So like this, one key also we can update, like directly or indirectly also we can update. Hope it's clear. So this is how we understood how to add the values. Then how do you remove the values? If you want to delete a values, so in a like in the previous cases, there is something called as a pop. But pop, from a dictionary, if you cannot use pop directly. Pop, like unless lists and the sets, it expects something. Means if you want to remove something, first you need to get the key. If you pass a key, only then it will remove. So means pop expects some key, then it will remove it. Okay, just now you removed it. What if you are trying to remove it again? As this key is no more present, it will throw a key error. So pop is something that if something is present, it will remove. If not, it will throw a key error. So whenever you don't want that exception to be handled, you pass the second value. This is very interesting. So unlike the others, so if you don't pass the second value, so whenever there is an error, if key is not present, it will throw an error exception. This is very careful. If it is not present, it will give the value. This is the difference. If I say maintenance dot none, so I get it. Dot keys, I got the value like that. Similarly, so if I want to get one value at a time, so I don't want to give the key, but I just want to remove the last value, means last given value. So every time, because list have an order, set don't have an order. Similarly, dictionaries also have an order, right? Hope you remember. So if I want to remove the last given key values, I can just go like this. If I do, it will remove the last given values. See what is the last value div version. After that, latest version. So you got. So pop item, see pop will give the value and remove the key. Whereas pop item will give the both key and the value also. And it will do based upon the last values. But if you want to remove something based upon a specific position, means like based upon key, you can do like a pop or else using del. Del is like a very powerful. If you can get a value, it can delete it. If you get an object, it will delete the object at all. So you know all these things. Similarly, so if you want to merge two dictionaries, so this was like recently one of the things, unpacking. So see, this is another interesting thing. If you have two dictionaries, if you want to combine them, you have used like dot update, right? In the same fashion, you can use something like star star a. Hope you remember when I'm doing string concatenation, I showed this operator plus plus means it will convert it to like key equal to value. But this plus plus a you cannot use outside. Only within the dictionaries we can do like this. Outside we cannot use it like this. Hope it's clear. So we can this is called as dictionary unpacking. Similarly, the same dictionary unpacking can also be done using something called as collections. There is one module called as collections. If I do with collections also, I can get it. There is something called as chain map. If I have a lot of dictionaries, I can just pass on all the dictionaries and it will add all of them in the backend. And also in latest Python 3.9 onwards, they created a new operator called as this pipe symbol. So only for dictionaries this works. If you do that, it will join all the key values. Multiple dictionaries if you have, if you want to join them, this is how we do. And if you have like, so as the same like, so you have these operations like plus equal to minus equal to, like that, this kind of, pipe equal to also we have. So when an operator is created, obviously its compound operator also will be created, right? So that's what it happens. We can do that also. Means if you just want to join two and update on A, so joining and so combining and updating A. So if you want to just combine, so you can use a pipe. If you want to combine and update, so this is what the update operation, right? So that's what it happens. So and also like there were some good interview questions to see. If you see the most common interview questions, this is like this. If I have a 0 and I'm piping with a this thing, so this is for like set operation. Even for sets also we can use this thing. So one among them you will get it. And similarly, the same operator we can use even for dictionaries. If I go for dictionaries, what will happen? So key column value. So in the backend 0 and false has the same value. So one among them will be there, right? So like this. So this is one of the assignment for you. So what is the point is that here you got the output. You need to analyze and let me know why it gave output like this. So you can check with multiple things, but a simple thing I will give is that. So as both are of having the same values, whatever it takes first that it will retain. That's the one thing I'm saying. But just you can follow the same to understand. So hope it's clear. And one last use case from dictionaries, if you see, is about if I have like dictionaries, I can create dictionaries in multiple ways. So if I say I have a dictionary, this is the first way of creating, right? Key colon value. Similarly, in a dictionary, you can say key equal to value, like this also you can create. It doesn't matter that this variable should be created outside. You can do like this in this way. Or else you can give a list of tuples, or else you can give something called a zip. I will tell you shortly what is that and do it. If you create in all these ways, it will create a dictionary in the same way. For you to understand, I am giving an assert statement. Assert means that, so all are equal, I'm saying. If it is wrong, it will throw in error, right? Just for you to understand. So what I'm trying to say is that here to explain, if I have something like a list of tuples, you see, I have a list of tuples. If I have a list of tuples, I can create a dictionary function. Till now, we didn't use the dictionary built-in function. We have seen list built-in function, tuple different function, all those things, right? So like that, we are using this thing. So for dictionary function to pass, say you remember, so I use this thing called as Python as a string. If I pass to list, I got list values, right? If I pass to tuple built-in function, I got like this. And similarly, if I go pass to set built-in function, I got like this, right? Hope you remember all these things. And if I pass this one, it will not do like that, because it expects two iterables together like a list of pairs. So that's the reason for a dictionary, if you pass like a pairs, it will do it. If you pass like a pairs, it will do it. So, and not only that, if you give anything like a pair, it will work. So whichever is coming in the starting, it will take that as a key. Second value, whatever it is getting, that it will take like a value. See, whichever is the first value, it is taking like a key. Second value, it is coming like a key. So but the main thing is that it should have a pair, two values only. But if you have created like a three values, see here in this case, each pair is having three values. Either inside it can be a tuple or set, a tuple or list, it's fine. So, but if I can, if I say dict of, dict of this data, because it has three values, you don't know what to be the key, what should be the value. Rather, if you give like a group among them, like a subgroups, you see now, the first one is a key, which is a string. Key can be a string, right? Fine. The second one is a tuple. So values can be a tuple. Similarly, first tuple, then this thing. What if you have inside one as a list? Then it won't work. But in this case, it works. It's clear? Now, one good example. Now you understood how to work with the dict built-in function. Let me give you one more example. How to create a dictionaries. So from a iterables. So creating a dictionaries from two iterables. Let's say if you were given two iterables, then how do you create from them? Say I have something like a cities. Cities means New Delhi, New York, Shanghai, Berlin. I have. Similarly, I have a countries. If I have like India, USA, China, dictionary, and German, I have two things. Now there is a built-in function called as zip. Zip is a built-in function. If you pass two iterables, it will create a pair out of it. In Python 2, it is a ordinary object. It will create a list. Then you can see everything. But in Python 3, we need to convert that else. If I convert to a list, then you can see all the values, key value, key value, key value, like that. So this is how it works. So from it will create a list of pairs. That's what important. I am converting to zip. list because zip is a lazy object. By default, when it is creating, you cannot see anything. If you want the output, you need to convert to something like a dribble, or you need to for loop in it. So now concluding is that if you want a pair of values, so whenever like zip of values are creating, this one, if you pass to a dictionary, don't you think that it will create a dictionary? See, instead of list, if I pass to a dictionary, did you see it created dictionary? So that is what. So if I assign this result to some variable, you got a dictionary, same thing. So if you want dictionaries, you need to pass to the zip function, and that zip result you should pass to the dictionary. If I pass countries as the key, you can get like this. But what you expect is both should be passed. Say like I can do any examples like this. So I can go for a dict of. So earlier you remember I told Python. So singly we cannot do, right? But if I pass to a zip, I can do it. So zip of say Python, comma say 6 if I do. So like uh, uh, range of 6, some 6 values, and that I am passing to a dictionary. Like this. If I do what each value is going into it, and it is doing in the same fashion. So what if I'm passing something like this? Say here I have zip of some tuple and list. Sorry, uh, like the string I have. I can do like this. And similarly, so there is one interview question. What if you have a keys and a values in a dictionary, and if you want to interchange the keys to the values? If let's say I have a my dictionary, here I want to reverse keys to the values and values to the keys. So we can tell like reverse dict is equal to, and whenever you're going for a thing, there are two things. If you want both key and a value in a dictionary, so what you do, my dict dot items. Hope you remember. If I do like this, I will get key and a value, right? If I print it, I'll get like key and a value. So what I can do, so in the reverse dictionary of value is equal to key. If I do, I'll get it. But the only problem is, so you should ensure that the value is also immutable. So if I ask now reverse dictionary, you see now what are the key values are there? Those were reversed right here. So this is all about it. So hope you understood everything. Any doubt till now? So, and one more thing that I want to say here is that we don't have a switch case here in Python. I told you about pattern matching is one thing, right? So like this, sometimes people use dictionaries also for that, for like making the things much more easy. A simple use case I will tell you is that uh, dict like switch case. Say if you want to do like a switch case with some example I'm giving. Say like I have one example where I want to do the addition, subtraction, division, and multiplication. So let's say I have one option. If the user is giving like, so in runtime input, I want to check whether the user is giving true or a false, or based upon the choice. So if I am asking user to give like 1, 2, 3, 4, if the user equal to 1, then say addition, do to like this if you have if else conditions. So what Python comes to with handy is that whenever you have these kind of things like this, you can better go with a dictionary. Means, so for a given condition, you have a value, means choice equal to 1, you have addition, choice equal to 2, you have subtraction, 3 like this, 4 like this, like this. If nothing was equal, then you have a default case. Don't you think in dictionary also we can do the same thing? We can create a dictionary with keys like what are the conditions we have and values of results, and you can do a dot get. Whenever you has given something which is not exactly the same, you get what you got. So like this also we can make use of it. Hope it's clear till now. Now, the last point after going to the thing is about comprehensions. Comprehensions is like a summary. So we have seen till now like list, tuple, set, and dictionary. Comprehension means like, so rewriting the for loop in a single line. So in one line, I can say that. So rewriting, so for loop in single line is comprehension. Comprehend, we tell like comprehend means like making the thing simple or crisp. So that's what we say, right? Say like I have some use case where I will have some values and I want to work on it. Say traditionally, if I have some for loop, I have a new dictionary. I go with like some range, and each time I go and get the values. Say for I in range of 2 to 9, each time I go and I append the values and I get the values. Now you see, you did a for loop and each time you added the values and you got the results, right? This is how you do traditionally. So the same thing you can do in a comprehension in a very simple way. So what are the new lists that you want to make? So new list is equal to, so you want to write in a dictionary as a set a list, right? You write in a list. Within that, what are the if condition is there? So write that if condition as it is. See how I am pasting? That's what the logic is. I remove the column. What I am appending every time I, the same I write it. Now, if I print like the new list, you get the same thing. Did you see? So the same thing I achieved. So that is the list comprehension because you are storing the comprehension results in a single list. Similarly, if I have the same value stored in a tuple, that is called as tuple comprehension. Of course, there is no tuple comprehension. So like similarly, set comprehension, dictionary comprehension, like the same thing. Similarly, if let's say I have a the same logic with some condition, say I have for some list where I'm again for looping, but if this time based upon a condition I'm adding I. So I have logic like this. If the same thing I want to do, so I can create another event list called as event list 2. I want to store in a list. I will store, and within that I write a if condition for loop. So in the for loop I write, and similarly in that I have an if condition. You see, so if condition should be at the end. This is what many people confuse. First for loop, then within that if condition, remove that column, and what I am adding every time I. So I write that I. Now, if I print like, assert, so even list is equal to even list 2. So don't you see? So first one printed, the second one I didn't print, right? Yeah. If I do second one and I do it, both are equal. And similarly, so comprehension with condition, so and getting squares means like, say this time, unlike the previous case, I want to take the same values and I have a condition also. But instead of just adding the value of I want to add the so squares. I have this is logic. So similarly, if I want to do the same thing, even squares 2 is equal to again like it. So square braces only. And what are the for loop you have? Take that first, place it, and within that you have an if condition. You see how that if condition will come here. And if that like within that I am doing an I square, right? That I square you place in the starting. You see, now you did two things. If I print like, even square and even square 2, both gonna give the same result. Did you see? Hope you are understanding how I'm transforming the things. With this, what like you need to understand. But there is a problem with the comprehensions. If you have a simple if condition, it works. So, but if you have like, say, two if conditions, then also it works. And two or three multiple cases you have, then also it works. So, like, um, say I have one more condition. Assume like here, I have an end operation, and so I not equal to, say I greater than 4. Assume I have something like this. So what are this extra condition is there, that also I can add here. That is also possible. I can do like this. No, what are I have condition as it is I'm doing. But if you have like a else condition, if only if is there, fine. Let's say I have a logic like this. If I have some values like if and else conditions, in that case, if I want to do the same thing like this here, so I can't do that. Means if I have a if condition, I do, and I cannot do the else condition. That is not possible. So, so that is a drawback. So, so else condition can't be placed comprehension. This is the one biggest problem. Then what is the solution? Solution is ternary operations. How to do ternary operations? First, I will tell what is a ternary operation, how to do that. Ternary operation means, so there will be a condition and there will be a true case and false case. This is how we have in JavaScript, right? So in JavaScript we have like this. So similarly in Python, we have something like that. Say I write something like say um, odd if true, else even, or like say greater if, so 12 greater than 3, else lesser. So did you see what happened? What are the condition you place in middle? If that is satisfied, the previous case, the first case. If the condition is not satisfied, the next case. See? So in all these cases, so final result it is true. Final result if it is true, this side, false the other side. And similarly, if I give more use cases, if I have like a correct, this expression is result is true, the first one, not the other one. So similarly, if I go with like many things I can do, you can just walk through it, same way it will work. Now, based upon these things, what are the learnings we made? Now, again, we can come back. See now, the last thing, what are we didn't solve earlier? Now we try to solve it now. So if I say here, even or odd 2 is equal to same dictionary. So this time, so what are the for loop you have? You write it, and you have an if else, right? That if else you write in a different way. How you write is like this. So what you're writing here, you are writing even. So if this condition is met, so only if you have like one if and one else, you can do it. If you have like multiple things, again, you can't do. So did you see now what I did? If I do like now, print of even or odd 2, you see both came same. So notice, so multiple, so elif ladder can't be done. Comprehension is for small things. Don't make too much complicated. If you have too many things, this is not the place for you to do all these things. So hope you understood what I'm trying to say. Now, one conclusion is that, so I'm taking anything like this, a simple for loop of a list, and I'm doing. Based upon the braces I'm doing, the result is called something. So as the result is stored in a square braces, it's a list. Second one, result is stored in a tuple. So it's called as a tuple comprehension. Basically, there is no tuple comprehension. There is something only called as a like this generator expression, which we'll learn in the next chapter. Next one is set comprehension. So set and dictionary comprehension. By the name it's saying, so we'll have like dictionary key comprehension, dictionary value comprehension, like that. But this is how we work with it. So hope it's clear. Okay. So based upon these things, we can also work with iterables also. If you go with like many iterables are there. So we can see about the iterables in the next class, and we can stop now.